Go through one of these. I'm going to go through 3 of them. The first one's kind of tricky. The second one's pretty easy, and the third one is a little bit harder. And then the fourth one is just kind of using algebra. That one's not too bad. And so what you want to do is look at one of these, which it says discuss and graph the equation r equals 4 minus 2 cosine theta. So the first thing that you want to try to do is to get it into a form that looks like one of these 4 things. And on a test, I will give you these 4 things, okay? So you don't have to worry about memorizing them, but you kind of have to know what they mean. And it says discuss the graph. And discuss means graph it, find the foci, find the intercepts, and and that's kind of what it means when it says discuss. It doesn't mean, talk with your friends about it, even though that would be nice.
So it means graph it?
Yeah, it means graph it, but also find the specific points, like the foci and the vertices. So in this case, the first step that I'm going to do is I'm going to divide everything by 2. Divide this by 2 and divide that by 2. And the reason I'm doing that is because then I have a new equation that looks like r equals 2 over.
You have to divide r by 2?
1 minus. No, you don't have to divide r by 2 because really I'm dividing by 1, right? When I divide the top and the bottom by 2, I'm dividing by 1. So this becomes 1 minus, it's like 1 cosine, so you have to divide this by 2.
Is it just like
So 1/2 cosine?
Yeah. So you have 1/2 cosine theta. Do you guys see what I did?
Why did we do this? It makes it simple.
Why did we do this? Because going back to my original thing, now it look, because you want to have a 1 out in front.
Oh, okay.
Okay? You want to have a 1 out in front. That's why you do that. So going back,
Does that mean p equals 4?
so that means that this is E right here in that equation. In every case, this is E. So it's kind of hard to see, to jump back and forth. Well, it's not that hard. So this looks like this equation, where this is E, and up top you have EP, and this is 1 minus E cosine theta, all right? And so I'm going to go back, find my thing. So I know that E equals 1/2. I also know that up here this is EP, right? So EP equals 2, and since I know that...
Does that mean this is an ellipse?
Right, yeah, we're getting there. Yeah, so I know that E equals 1/2, so plugging 1/2 in here, I get 1/2 times P equals 2, so P equals 4. And since this, very good, since this is less than 1, right? That means that it's an ellipse. And since it is a cosine, that means that it runs along the x-axis, or they call it the polar axis. X-axis ellipse. In other words, it's stretched along the x-axis if it's cosine. And then P equals 4 tells you where the directrix is. Okay, so this is kind of the weird part. So I'm going to try to draw a graph. I don't want dotted lines. I want solid lines. I want arrows on my lines. I'm so picky. So just sketching, okay, this ellipse in here. What's this trash can doing here? Yeah, all right. So I know that this is going to be an ellipse. Watch this. I'm getting so good with these tools now. Okay. I know that this is going to be an ellipse going something like along the x-axis, except it's going to be centered on. I'm not getting so good. Let me try that again. Okay. If I start down here, it's going to be something like this. However, it's going to look more like this. And the reason it looks like that is because if always one focus with all of these, with every single one of these, says the polar equation of a conic with focus at the pole. So every one of these is always going to have a focus at the pole. So what that means is, because it's kind of being generated from there, so this means the focus is at the pole. And with an ellipse, with this particular one, going back again, it says the polar equation of a conic with focus at the pole directrix perpendicular to the polar axis at a distance p to the left of the pole. So in other words,
I thought only parabola was happening.
yeah, I know, but this definition, this polar definition, and ellipses and hyperbolas also have directrix, okay? And so to draw in that directrix, if it's to the left of the pole, it means that it's kind of pushed over onto this side. If the directrix were on the right side of the pole, it means that it's kind of pushed over onto the left side. So one focus is going to be here, and one focus is going to be here, in which we're going to find out those points. The center, hold on, the center is going to be somewhere over here, and then I'm going to find this point, that point, and this point. Okay, so, and that's kind of what it means. You have to find the coordinates of the foci, the coordinates of the center, the coordinates of the vertices, here, 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 and here, and then the coordinates of the y-intercepts, okay? Hold on, what was your question there, Drew?
So by pole, do they just mean origin of the
Yeah, the pole is the same as the origin, yeah. Okay? And so I'm going to just draw it in the directrix to kind of show you it. That there's a directrix over here, and the equation of that directrix, it's 4 unit, or it's p units to the left of the pole. So this directrix would have the equation x, or not x, y equals x equals, gosh, sorry, x equals -4. All right, that's the equation in that directrix. I know this is 0, 0. All right, now how do I find some of these other points? This is what you do.
X negative y is x equals -4.
Isn't that line right there
X, yeah, because it's p units to the left of the pole.
Wait, how do you know it's to the left?
Because if I go to this looks like this, right? The polar equation of a conic with focus at the pole and directrix perpendicular to the pole, polar axis, at a distance p units to the left of the pole.
too? So wait, I didn't say that when you not know where it was.
Yeah, well, if it looks like a sine one, then it's going to be parallel to the polar axis, okay? Which
But how do you
means,
know whether it's up or down?
because sines go horizontal.
No, but like how do you know like where it's a direction?
Yeah, just from P, okay? Because if it's minus, it's to the left. If it's plus, it's to the right, okay? If it's plus here, it's above, right? And if it's minus, it's below, okay?
Which is the polar axis?
The polar axis is the y-axis. This is the polar axis. This is, no, that's wrong.
What?
Perpendicular to the polar, this is the polar axis. Okay, the x-axis is the polar axis. This is the y-axis, okay? So the next thing I'm going to do is plot some points. And the way I plot those points is by making a little table. And the nicest, and you're going to do this in r theta form, okay? And when you do that, you're going to plug these points in to this equation just because it's easy. You could plug into this equation too, but it's easier to just plug in to this equation. The easiest one to plug in is 0, okay? And when I plug in 0 in here, I get 4 over 2 minus cosine of 0. What's a cosine of 0? 1. So I get 4 over 2 minus 1, which is 4. Okay? So what that says is that on this graph, I have a point that is out 4 on the polar axis and move around 0. So even though these points are in polar form, I'm going to,
I
what?
thought the focus is going to be at 4. Because T
No. No, this is a point on the curve. The foci are not foci won't show up here, right? Because they're not on the actual,
I thought the foci were 4.
not the foci, the directrix is
Oh,
4
okay.
units to the left of the pole. Okay?
So the foci in the direction
The directrix
The-
works differently.
Okay.
Yeah, it works differently in this, okay? And all it says is that the distance from here to here, or the distance from here to here has to be less than 1.
Why is that
okay?
necessary to have a directrix?
It's just one way, another way you could generate the ellipse, okay? You don't have to actually sketch it, it just kind of tells you where it is, all right? And it tells you the orientation of the ellipse, okay? And to generate, going back to generate this ellipse, if I found all the points, well, that doesn't really make sense, but where this over this, the distance from here to here and the distance from here to here is always, this over this is always less than 1, then I could generate this. Oh, see, now you made me. Okay, I'll fix it. Okay. Yes, Jay.
So when it says with the focus at the pole, how do you know which focus to use?
Well,
Like, can you just say?
because if the directrix is to the left, the other focus has to be over here. Okay? If the directrix were to the right, then the other focus would be over here.
Okay.
Okay? All right. So now we have our data. We have R is 4, 0, so we plotted this point, and I'm going to write these points in rectangular form, 4, 0. Okay? Now I'm going to plot another point where I'm going to plug in theta equals pi. Right? So when I plug in theta equals pi in here, what's the cosine of pi? -1. So I'm going to get 4 over 2 minus -1, which comes out to be a nice uneven 4/3. Okay? And so,
Would it be
no, it would be positive 4/3. So what that means is I come out here 4/3, wherever that is, and then I rotate around to pi. So in rectangular form, that's this point, and what would that point be if I were to come out here 4/3 and rotate through pi? What would it be in rectangular form? In XY coordinates? Good. It would be -4/3, comma, 0. Do you understand that? Okay, because if I come out 4/3 in the x direction and then rotate through pi, then the distance from here to here is going to be -4/3.
Because it's 100 meters.
Okay? So now what you can do is find the center, because I know these 2 points. You see that? Right? And so the center, I need to change colors. I don't like red. Center, okay, is going to be at the average between -4/3 and 4. Right? So center is going to be at -4/3, the midpoint between -4/3 and 4. So the way, remember, you find the midpoint, you add together the x coordinates, and you divide by 2. You would have to add the y coordinates too, but those are both 0, right? So -4/3, 4, what is that? That's kind of ugly, not that ugly. That's 12/3, and that's 4/3, so that makes 8/3, doesn't it? That's 4 can be written as 12/3. So I'm going to add together these two things, and I get 8/3 divided by 2, which is the same as taking 8/3 and multiplying by 1/2, right? Which is 8/6, which is what? 4/3. So this center right here is at 4/3, positive 4/3, comma 0, okay, in XY coordinate. Now, the other thing I have to find is this focus. Well, this focus is just going to be the same distance as this focus. This is a focus, right? So here's focus 1. So where's focus 2? If this is 4/3 away from here, what's this focus going to be? 8/3. Nice. Okay. So this point would be 8/3, comma 0, because it's the same distance from the center as this one is. Okay. And then I can find these 2 points. And the way I find those 2 points is the y-intercepts.
Why would you want to find that?
Just because it helps you graph it, if you were graphing it by hand, okay? It would help you graph it.
Okay, on a test, maybe expect.
Yeah, you would be expected to find those 2 points. All right? And so those 2 points, to find them, you plug in pi over 2 radians into this equation. Okay? And I can plug in pi over 2 in there, and I get 4, what's the cosine of pi over 2? 0. So I get 4 over 2 minus 0, and I get 2, right? So what that means is I come out here 2, and I rotate through pi over 2. So what would be the rectangular coordinates at this point? 0, 2. Okay? And guess what this is going to be down here? 0, negative 2. Okay? So if I were to plug in 3 pi over 2 into here, I would get 0 as well. Oops. I would get 0 as well, and then I get out 2 again. So that means I come out 2, and then I rotate through pi over 2. So this point down here is 0, negative 2. Okay? I'm almost done. Last thing. Okay? Now the last thing I want to do is find out the stretch. Okay? From here to here. Remember that? Okay? And in other words, I'm going to find B. B? Remember B? This is A. The distance from the center to here is A, and then the distance from here to here is B. And I know what C is. It's the distance from here to here. Okay? And in an ellipse, I know that C squared equals A squared minus B squared. And I know C is the distance from here to here. So what's C? 4/3. So I know 4/3 squared. Now you have to be good at fractions. Okay? Equals A squared. And A is the distance from the center to here, or from here to here. So that would be, what is that? 4/3. Wouldn't that be 8/3? Yeah, 8/3, right? Because this is 4/3 from here. And that's negative 4/3. That's right. So that would be 8/3 squared. 8/3. I know this is the hardest part, the ugliest part. Okay?
Just arduous.
It's arduous. Ooh, that's a big word. What does that mean? I know. 64 over 9 minus b squared. So when you square both of these, you don't forget you have to square the numerators and the denominators. And then you subtract, and what's 64 minus 16? 16 minus 6, is that 48? I think so. You get 48 ninths equals c squared. So c is equal to the square root. What? B squared, sorry. B, gosh, B squared. I really studied this last night because I didn't want to mess up too much. And this is one of the things I always dread because kids have a hard time with it. Okay? B squared, so that's 48 over 9, which I can pull out a 16 out of here. So on the top I could write this as 4 root of 3, and on the bottom I could put that as 3. Because it's square root of 9 is 3. And 48
equals square root of that, not b squared.
What? Oh, sorry. B, so B is 4 root 3 over 3. Okay, whatever that is, I'm not sure. 4/3 of 1.732. I don't know, close to 2, I'd guess. But, okay, but a little bit more than 2.
On the test, you would just do the root of 48.
Yeah, that'd be fun. Okay, so these points right here, since the x coordinate is the same, okay, this one would be, the center is at 4/3, comma 0, so it's going to be 4/3, comma 4√3/3. And this point down here would be 4/3, comma negative 4√3/3.
I don't think I'd ever be able to do it one way.
Yeah, I know it's hard, okay? So I do have one on a test like this, and then I have one on a practice problem. Okay, should I pause for a minute?
Yeah.
Okay, pause. I'm gonna show you something cool, class. If I go to mode, and I make sure that I am in polar mode, okay, which I am, and I go to y equals, and I plug in this equation, okay? Notice that r pops up, and I get 4 divided by 2 minus cosine theta, and you also got to make sure that you're in radian mode. Okay? Radian mode, did I check that? Mode, radian, so I'm in degree mode, so I want to be in radian mode. And then, I'm not sure what my window is, but probably I want to go from 0. What if I set this from 0 to 2 pi, my thetas? Is this pi? 2 pi. And step I don't think matters, and my x min, that's obviously way too big, right? So let's say my x min to like -3, whoops, -3 up to, since the longest thing I had on the x-axis is 5, right? I'm going to change that to 5. And if I hit graph, I get a straight line because I don't know what the heck I did. Y equals 4/2 minus cosine theta. Window, what did I do? 0 to 2 pi. Step x min is, I see what I did. Y min is too small, so my y min, let's set that to -3 as well. -3. And I'm going to set my y max to +3. And then if I hit graph, now look at that. I get that nice.
What'd you change to
So
make it work?
it's pretty cool. I changed my Y window. Okay. So that's pretty cool. All right. So now we're going to graph the parabola. I think I'm going to skip the hyperbola for today. But you guys could look at the example in the book because I won't run out of time to do the hyperbola. But basically it's done very similarly. All right. So let's go to the parabola because that one's pretty easy. Okay. So the next one we're going to look at is this. Let's discuss the graph real quick. First thing I'm going to do is divide everything by what? 3. Divide this by 3, divide this by 3, divide this by 3. Okay? And I get 2/1 plus sine theta, right? And E is equal to 1, which means it's a parabola. And I also know that EP equals 3, which might mean that P equals EP equals 2, sorry. EP equals 2. So P equals 2, right? And now this one says, so just graphing, this one's real quick. Watch. I'll use a dotted axis, doesn't matter. No, let's not use a dotted axis because it doesn't matter. Okay. So this one, you don't have to plot that many points on this one because, first of all, I know that this is a parabola. They always have a focus at the pole, right? Since it's sine, it's going up, down, okay? Since it's sine, it's going up, down. That's basically what that means. And since it's positive, It means the directrix is up here, okay? And so now I'm going to draw in my directrix, which is P units away, P units.
I'm making jokes right there.
Yeah. I don't want that to be done. So I'm going to draw in my directrix, which is up here, at y equals 2, right? Do you guys understand that? And since I know...
Positive, it's up there?
Yeah, because this is positive. It's up here. And the other thing, I know this is pretty easy, because I know with a parabola...
Yeah, but
that
in the other problem, P was 4, but it was -4. So we put that away. Shouldn't it just be up there because of...
Yeah, but it was negative. It was, in the last one, it was negative, right?
Wait, no, I think the last
P
one
was 4.
Yeah, P was.
Yeah, but it says, since it's a minus sign, going back, where'd my sheet go? See, going back, it says 4, if it's minus, it's to the left of the pole. If it's plus, it's to the right of the pole, okay? In this case, it's plus, so it says, we're looking at this one, okay? The equation is a conic with focus at the pole directions parallel to the polar axis, distance P units above, okay? So now, since I know it's a parabola, okay, that's not too bad, because I also know that in a parabola, the vertex is halfway between those two things, right? And so what's my vertex at right here? If this is 2 and that's 0, what's this? So that's the point 0, 1, and that's just the top of my parabola. And the only thing I really have to find is...
Wait, is the 0, 0 the focus?
What? 0, 0 is always a focus. Okay, so there's always a focus on the pole, at the pole, they call it. Okay. So now I'm just going to do a real quick, easy table, okay, where I'm going to plug in r theta, and I'm going to plug. I want to find this point. All right. So I'm going to plug in theta equals what?
Pi.
0. Okay. I'm going to plug in theta equals 0. Whoops. What's the sign of 0?
0.
0. So I get 6 over, so when I plug in 0, I get 6 over 3 plus 0, which is 2. Okay? 2. not 1. Okay? So this point over here is 2, 0. And you can plug in the other point if you want to, but you don't really have to, because parabolas are, these is going to be symmetric, right? And so what would this be point over here?
Negative 2.
-2, comma 0. And so what I get is a parabola that kind of is going from this point down through that point and down and from this point. The parabola is easy, right? Okay?
So
And you can put that in your calculator if you want to, and you would see a parabola, okay? I'm not going to have time to do the hyperbola, but it's done the same way. The hard thing is finding, it's,
So those are the only points that we have to have.
yeah, for the parabola, that's all you really need to have.
Can you
Okay?
put in a parabola one on the test, please?
I'll try, okay? And then the last thing is just converting one of these from polar form to rectangular form.
Oh, snap.
This is pretty easy. So you just multiply through by 3 minus 3 cosine theta, and you get r times 3 minus 3 cos theta, 3, why did I write cos twice? 3 cos theta equals 1, and then distribute through the r. So you get 3r minus 3r cos theta equals 1. And 3r, well, first I would bring this over by itself. 3r equals 3r cos theta. What's 3r cos theta equal to? 3x, very good. 3x plus 1, okay? I'm not quite done converting it, because r, this is what a lot of you guys messed up on that last quiz, r is equal to the square root of x squared plus y squared, on the last test, equals 3x plus 1. I'm not done yet.
Wait.
Because, what?
Oh, I see.
Okay, see what I did?
No,
No?
I don't.
R, since r squared equals x squared plus y squared, right? R squared equals x squared plus y squared. And so r is the square root of x squared plus y squared.
Oh,
Yeah?
that makes sense.
Okay. So now I'm going to square both sides. So I'm going to square both sides. And when I square both sides, this comes out kind of nice. Watch. This becomes a 9. This becomes an x squared plus y squared. Because you have to square this and you have to square this, and squaring a square root takes that away. And this becomes, when I FOIL it, just trust me on this one, 9x squared, 3x times 1 twice gives you plus 6x plus 1. Okay? What happens to the 9x squareds?
They go away.
Those go away. Okay? And so I get is y squared equals, did I mess up? I messed up.
Don't you distribute the
Because they asked, this should be a 9y squared. 9. Okay? So 9y squared equals 6x plus 1. And this is the equation of a what? A sideways parabola, right? And so really you should write as y squared equals 6 over 9x plus 1/9. And then y squared equals, the way they really want it is you to factor out this 6/9 x plus, how do I make this into 6/9? That's 1/6. That would be in standard form that we know. This is 4p, and that's h, and that's k. But that's kind of tricky. If you just got it to here and you said it's got to be a sideways parabola, that would be fine.
Where did
Okay.
those 3x plus 1 come from?
Where did 3x plus 1 come from? Because r cosine theta is equal to x.
Okay.
Okay? All right. What did I do wrong? I didn't do anything wrong. This is your homework. These 1 through 6 are short questions. And I think I have a parabola, an ellipse, a hyperbola, and then converting one like that for your own. Okay? Try to do the hyperbola. We'll talk about that in class tomorrow. And remember, you heard it right here on Mr. Leader's fantastic and inspiring math channel.
Roller derby.
Roller derby.